this is the continuation of the third video. We simply considered the double integrals as well as how we evaluate them and also how we apply to find a volume. Then even though we have considered all of those, we did not consider the general form. So, the general form of a double integral is like this. If you put dx first, then you may have limits of you may have limits carrying the other variable y. However, in the last integral you have constants. The integrand may consist both x and y. So, when you consider x, the pertaining integral may have limits of the remaining variable y. However, in the last integral, I mean even though this appears as the first integral, when you evaluate it, we consider this at last. Therefore, here you have constants as limits. But if you have the other way around, if the order is reversed, then dy comes first. So, here again you can have the integrand consisting of both variables. Since x is going to be considered later, you can have you may have limits carrying x like this. You may have functions of x here. You may have, sometimes you may have constants, right. And in the last one, of course, here it appears as the first one, you have constants, right. Here this is the type when x comes first, this type when y comes first. Now, we will move to the triple integrals. In the triple integrals, you have one more step, that is all, right. It is not really a big deal, it is again as simple as this one, but the only difference is that you have one more integral. Now, this is a triple integral, the part B in section 3.1. The general form looks like this. The integrand might consider all three variables. We will consider only this form. When x stays as the first variable, you can have the limits like this. They may carry both y and z. When you go to the next level, now the variable x has already been considered when you come to this level. Then still z is not considered, because first in the first case you consider x, here you consider y. While considering the variable y, still this is untouched. Therefore, you can have z in the limits. However, in the when you consider the last variable, the corresponding integral is this one, here you should have constants. Okay? Again, in the first case, when you deal with x, both y and z have not been considered. Therefore, you can have limits like this, consisting of the variables that have not been considered so far. When you go to the next level, y, right, this is the corresponding integral, right. Let me, for the sake of clarity, let me do it like this. Right. Here, you can see that at this level variable z has not been considered. Therefore, you can have z as the limits. Okay. Now, we will consider a couple of examples. Let us evaluate this one. Here you can see all the limits are constants. For the sake of clarity, I considered a simple example. So, integrand has both x and y. So, first use a pair of braces just for the sake of clarity. I mean, it is not a necessity, it is not a must, but for the sake of clarity I use this one. So, here again it is exactly the opposite of the partial derivatives, right. Here, since the variable of our interest is x, x is a variable, but y and both y and z, the other variables are considered as constants. So, here 6y, you leave it as a constant, x is the variable. When you integrate x, you get x squared over 2. Limits are from 0 to 2. So, you can simplify this a little bit. 2 times 6 divided by 2 is 3. So, limits are from 0 to 2. Again, I will move to this here, move to that portion. When you plug in 2, you better write this one. I mean, it is again not a must. However, since 3 variables are involved, you better know what variable that you are considering at this moment. Therefore, x is equal to 0, this here it is 2. So, if you plug in 2, 2 squared is 4, 4 times 3 is 12, 12y minus 0. So, 12y minus 0. After that, you can simplify this. Now, you are in the next level. Now, this is something that we are familiar now. Now, this is a double integral. Again, you introduce a pair of braces just to make it little simpler. Now, when you integrate this one, you get y squared over 2, right, which is 6y squared. Now, you plug in the limits. When you plug in 1, you get 6. When you plug in 0, you get 0. So, 6 minus 0, which is 6. So, when you integrate this one, when you integrate 6, you get 6 z. Limits are from 1 to 2. Now, you plug in 2, you get 12. When you plug in 1, you get 6. So, we will end up with 6 as the answer. Now, let us go through one more example. Here, you can see that there is a variable in the limits, but that is fine, because here the last variable we are going to consider is z. So, in that case you have constants, but before that you can have z in any of those integrals, I mean as a limit of any of those integrals, but this should be these two should be constants. Now, again the integrand carries two variables x and z. Again, for the sake of clarity, let us use a pair of braces. So, x is the variable, therefore, x squared over 2 is the answer. Here z is a constant like 5. When you integrate 5 with respect to z, sorry, x, you get 5x. Likewise, here it is zx or xz. Limits are from 0 to 1. Now, you will plug in the limits. When you plug in 1, you get half plus z. Again, x is the variable of our interest. When you plug in 0, you get 0. You do not have to write it. So, this is what you get. Now, you are in the next level. So, put a pair of braces. Now, y is the variable. Now, note that this should be treated as a constant, because y is the variable. Therefore, it is a constant. So, when you integrate it, constant times y, constant times y. Limits are from 0 to z. Now, you plug in them. When you plug in z, you get that, right. When you plug in 0, you get 0 here, right. Again, when you plug in z, you get half plus z times z. When you plug in 0, you get 0. Now, simplify, you will end up with this. Limits are from 0 to 2. Now, plug in 2 here. First we will integrate it. Again, this is a simple integral, you know how to do it, right. After that, you plug in limits. So, when you plug in 2 there, first let us simplify this. So, when you plug in 2, you get 2 squared is 4, 4 over 4 is 1, here 2 cube is 8, 8 over 3 minus 0, which is 11 over 3. So, that is how you integrate that is how you evaluate triple integrals. After this, we will go through an example of say evaluating a volume or something. Then towards the end, we can consider transformation, the transformations or the coordinate transformations involved in double and triple integrals. Okay, thank you.